This lesson is on solving equations, particular mixture problems, and percent problems. So a little bit of review, if you took the class before this, we spent a lot of time with finding percents of numbers and such. So just a reminder, to change a percent to a decimal, we need to move the decimal to the left 2 places. So just a quick little review. If we had 2%, to change 2% to a decimal, we would move the decimal, and every number has a decimal here if there is not one. So we're going to move it over 2. So it would equal 0.02. If we had 32%, to change it to a decimal, we're going to move the decimal over 2. So we would have 0.32, so 0.32. Okay, so we move it 2 to the left to change it into a decimal. And then we know that the word is represents equal, and the word of in math means multiply. So to make sure we understand that, I made up an example before we do example 1 that's more of, most of us could probably do in our head. So if we look here, it says 50%, and we know that on a test, let's say, you can get 100%. So 50% is half, right? So it's saying 50% of 8. So what's half of 8? It should be, is what? It would be 4. Now what we're going to do instead, so that we can do the ones that are a little bit harder, we're going to go ahead and change this 50% to a decimal. So if we move the decimal over twice, we get 0.50, and we should know that we don't need a 0 at the end of a decimal, so we can get rid of that. And then the word of means multiply, and I'm going to put parentheses for multiply so it doesn't get confused as a decimal. So 50% of 8, and then is, we don't, is means equal, and then it says of what? Well, we don't know, so I'm going to have that be x. So to figure out what 50% of 8 is, I would need to multiply 0.5 times 8, which would get us 4. So we're going to take out the word of and put multiplication. We're going to take the word is out and put an equal sign. Now there is another way to solve these percent problems using proportions, but we're going to stick with the percent equation written as a sentence like this, just because it's going to help us with what we're going to do next. Okay, so if we take a look at number 1 in your notes, it says the number 63, so the number 63 is, means equal, what percent, we don't know, so I'm going to have that be x. X is going to represent the percent. So it says is what percent, the word of means multiply, 72. Now, in an equation, we don't use the dot for multiplication. We usually write it as 72x. And now we have an equation to solve, and when we want to get rid of the number that's right next to the x, we're going to go ahead and divide. So when we do 63 divided by 72, we get 0.875. So now if we go back and read our problem, it says the number 63 is what percent? So this should be a percent. So we need to write it as a percent. So a percent symbol goes here on this side. So that helps me remember that I need to move this decimal twice back to the right. So it would be 87.5%. So the number 63 is 87.5% of 72. Now, if we take a look at the 63 here and the 72, those two numbers here are pretty close to each other. And when they're pretty close to each other, we should get a high percentage, which 87.5 is a high percentage. Think of grades, you know, that's a good grade in 87. So let's go ahead and try example 2. And feel free again to pause it, try it, and then listen to the explanation if needed. So the number 120 is 15% of means multiply. What number? We don't know. So this is going to be our x. We don't know what it is. So we know that we cannot multiply with a percent symbol. We know that percent means out of 100. So that means we're going to move the decimal to the left twice. Again, that's review. So now we have 120 equals 0.15x. And to solve for x, we're going to go ahead and divide by 0.15. And that's going to get us what x is. So 120 divided by 0.15, we get 800. So now let's go back to the original problem, make sure it makes sense. It says the number 120 is 15% of what number? Now notice we had here 120 and then we got 800. Those numbers are like 700 away about. They're pretty far numbers apart. Now look at our percentage that was in the problem. The percent is low. 15% is low. The distance between these numbers should be further away. All right, so that was just a little bit of review with some percent problems. Now let's go ahead and take a look at example 3. So go ahead and read example 3, think about it, think about how the setup would look like, and then push play and let's see how you did. Okay, so we have a chemist and he needs 12 liters in which half of it, so 50%, is acid solution. So we have a solution, so some sort of liquid, and half of the liquid has to be acid for a lab experiment. And then it says that a stockroom has only 40% and 70% solutions. So he goes to the stockroom, and none of the liquid, none of their solutions are 50% acid. So he's like, well, how much do I need to mix together in order to produce one that has half of it is acid, 50% of it is acid. So let's have this one be the 40% and this one be the 70%. And we're going to mix them, and mix them means add. So we're going to put them together and then we're going to pour them. We're going to pour some of this into a container, and then we're going to pour some of this into the container, and when it all mixes together, it should be 12 liters. So this should be 12 liters, and it should be a 50% solution that has acid. So it says, how much of each should be mixed together? So we don't know how much this is. So it doesn't matter whether this one is X or the 70% is X. So I'm going to let, since I don't know what the 40% is, I'm going to let X represent how much. So how many liters of the 40% solution. So X is going to represent how much of this do I need to pour into that container. So we don't know how much. However, though, together it says that this one is going to have 12 liters. So however much I pour in of this one and however much I pour into this, together it has to make 12. So therefore I know if this is X, let's say this was 5, then I would know that this one would have to have the rest of it. So if we take away how much we pour here, if we take away how much we pour here from 12, that would leave us with how much of the 70% solution. So, for example, to use some numbers to help us make sense here of why this works, let's just pretend here that I pour in 7 liters of this. So let's say that this was 7 liters. Well, together, this one here, this one plus this one, when it goes into this one, it should be 12. So if I put 7 here, which that's what I made up for x, if I put 7 there, then 12 minus 7 is 5. And do you see that together it has to be 12. So that's why this expression and this expression works. Okay, so now let's get to our equation here. So of all this liquid that's in here, 40%, almost half, 40% of it has acid. So we know that the word of means multiply. So we're going to go ahead and change the 40% to a decimal. So 0.4. We don't need a 0 at the end of a decimal, so I'm going to get rid of it. But 40% of this, so I'm going to put x, because that means multiply there. Plus, if we mix, so we pour in this, so that's what this represents here. The amount we're pouring in that we're going to put into this here. And then we're going to mix it, so that's what the plus means. We're going to mix it here with the 70%. So we're going to change the 70% to a decimal, so 0.70. We don't need that 0 there, so I'm going to go ahead and get rid of it there. And of here means multiply, so we're going to multiply by this. And all together, it should equal 50%. So I'm going to move the decimal over twice. So we get 0.50, but we don't need that 0 there at the end of a decimal. And half of it, half of the 12 liters should be acid. So half of the 12 liters. Okay, so let's make sure this makes sense one more time here. So we are going to take this, put it in here, plus this, put it in here, and it should make this. So that's why we're setting it equal here. So let's go ahead and solve that equation now. So first thing, when we solve an equation, we need to simplify. So we're going to go ahead and distribute here this 0.7 through to the whole entire equation. Okay, so we have 0.7 times 12, which is 8.4. And then we have 0.7 times -1, which is -0.7. Then we're going to bring this down. Oops, forgot the x over here. Okay, and then we could simplify this. 0.5 times 12, half of 12, is 6. Then we're going to go ahead and combine the like terms on the left side. We could put the x's together because they both have x's. And 0.4 minus 0.7 is -0.3x. Definitely want to make sure you have your calculator for these problems when you take the next test for sure. So the next thing is we're going to have to take away this 8.4. And then we have here 6 minus 8.4, which is -2.4. And then the very last step, when we have the variable term isolated, we're going to go ahead and divide by -0.3. And then negative divided by a negative is a positive. And then we put on our calculator 2.4 divided by 0.3, and we would get 6. Oh, no, I'm sorry, 8. So now let's make sure, well, what was X? What did it represent? So if we go back to our beginning here, we let X represented how many liters of the 40% solution. So what we found, the 8 that we found, the 8 liters, is X. So it's telling us that we're going to pour in 8 liters of this mixture here. We're going to pour it in to our mixture here. So 8 liters of this, 8 liters is going to come from this solution here. So 8 liters. And then we want to know, well, how much of this? So since X is 8, we're going to put the 8 here, and 12 minus 8 would be 4. So we're going to pour in 4 liters of this. We're going to pour it in here. So we're going to have 8 from this one. We're going to pour it in, and then 4 of this and pour it in, and that's going to make 12. And when you pour those two solutions in, only half of it, 50%, will be acid. Okay, so we have another mixture problem here. I would pause it, try it on your own, and then watch the explanation. So we have how many ounces, so this time we have ounces, of a 15% alcohol solution. So one of these containers is going to have 50% alcohol. And then it says how much must it be mixed with, or how many ounces of 15% alcohol solution must be mixed with 4 ounces of 20% solution. So we're going to mix these two together, and it tells us this one's going to be 40 or 4 ounces. So how much we don't know how much this is, but how much needs to be mixed together so that this one, when they've mixed into here together, this one will be 17% alcohol. And we don't know how many liters because it didn't tell us. So I'm going to go ahead and let X represent this unknown. So I'm going to have X represent the amount of this that needs to be poured into this. So that's what my X is going to represent, is how much of this here. Okay, so we have that 15% of it, so I'm going to make the 15 a decimal, so 0.15. So 0.15, and we don't know what this is, so X, and then plus 20%, so I'm going to make this a decimal, so 0.20, but we don't need that 0 at the end of a decimal. 20% of this, they told us, it's 4. So it wants to know, we already know we're going to pour 4 ounces into this. And then it's going to equal 17%. So move the decimal over. And we don't know how much is going to be in here. We know that we have 4. So we have the 4 ounces. And then we have this that's going to be poured into here. But we don't know how much that is. But we know that it represents an X amount because we don't know what this is. So this is representing X. We're going to pour in that amount, whatever X is, in there. So all together, it's going to have the 4 ounces plus it's going to have whatever amount we poured into here in there. So we have our equation, and now we're going to solve it. Okay, so first thing we're going to simplify so we can multiply here. So 0.2 times 4 is 0.8. And then we're going to use the distributive property over here. So we get 0.68 plus 0.17x. And now we are going to get rid of one of the variables. It does not matter which one. I'm going to get rid of the 0.15 here, x. Okay, so 0.17 and negative 0.15 is going to make positive 0.02x. So now I want this to be by itself, so we're going to go ahead and subtract 0.68. And then we have 0.8 take away 0.68, and we would get 0.12. And now to get rid of the number next to the variable, to make it just 1x, we're going to divide it by 0.02. So when we divide 0.12 by 0.02, we would get 6 for x. So let's go back and make sure we know what x represents. Okay, so we got that x was 6. So let's read what x was. So if we look here, x represents the number of ounces of this solution. So that's telling us that we're going to pour into this 6 ounces. And we already knew we're going to pour in 4 of this. So there's going to be a total of 10 ounces here. So all together. Now the question asked how much of this. So we know 6 ounces. Okay, let's go ahead and try one more mixture problem. So Dr. Giles was responsible for refilling the eyewash stations in the chemistry lab. He needs 6 liters of a 3% strength wash to refill the dispensers. However, the supply room only had a 2% and a 5%. But he needs it to be 3%. And he wants 6 liters, it says. So it asks us how much of each solution should be mixed to produce a 3% strength eyewash. So we're trying to figure out how much do we need to pour into here from each one of these. So I'm going to let x represent how many liters I pour in of this. I'm going to have x represent how many liters. So I'm going to let x represent the liters of the 2% strength eyewash. Okay, so if I pour in an X amount here, the amount that I pour in here has to be the leftover. So, for example, if X was 4, since the total should be 6, then I would know that the rest of it would have to go here. So, if this is 4 and if I take 6 and I subtract the 4, which really we don't know if it's 4, but if this was 4, then we would get 2, and 2 plus 4 is 6. So that's why that expression, 6 minus x, works here. So again, to just make sure that's clear here, the reason why these two are the correct expressions is because x represents how many liters of this. So if we poured In this jar right here, if we poured in, let's say, 2 liters, let's say this was 2 liters, and then I put the 2 here, 6 minus 2 is 4 liters. And again, all together, it should make 6. Okay, so now let's set our equation up here. So we need to make this a decimal, so move the decimal over 2. So we have 0.02, so 2% of this is eyewash solution. So we're going to put an X, and then plus it has to be mixed with 5%, so we move the decimal over twice. And then multiply by the 6 minus X, and it equals 3%, so remove the decimal over 2. And 3% of, and of means multiply, the 6 liters. So let's go ahead now and solve that equation. Okay, so first thing here, I'm going to go ahead and distribute this to the parentheses. So 0.05 times 6 is 0.3. And then 0.05 times negative 1 is negative 0.05x. And then 0.03 times 6 is 0.18. Now we're going to go ahead and combine the like terms here on the left side. So 0.02 minus 0.05 is negative 0.03x. So our goal is to get the variable term by itself, so we're going to subtract 3/10, so 0.3. And then the last step to get rid of the number that's in front of the variable, we're going to divide by negative 0.03. So we get x equals 4. So let's make sure we understand what we just found there. Okay, so we got that x was 4. And if we go back and read our let statement, it says x represents the number of liters of 2% strength. So that means I'm going to pour in from here, I'm going to pour in 4 liters. And then we want to know how much of this one I'm going to pour in. So how much of this one? Well, if we put the 4 back in here, 6 minus 4 is 2. So we are going to pour in 2 liters of this one. And again, all together, this plus this got us the 6. So it all matches and it checks out.